For this video, I'm going to review how to facilitate the Notice and Wonder warm-up for Unit 7, Day 16, Lesson 9A, Equivalent Equations and Functions. The focus of question of this lesson is what is important to pay attention to when looking for solutions to equations, functions, and graphs. So if we jump down to the warm-up, the warm-up has two parts. First, there's a Notice and Wonder piece, and then there's a space for students to explain or show how these equations are equivalent. The purpose of this discussion is to remind students of some standard moves for rearranging linear equations. And this is going to set them up for success when they work with quadratic equations. So you really want to emphasize the different moves that were taken. So first question, what do you notice? Somebody might notice all of the equations are equivalent. We want to emphasize that. Some students might notice they use the properties of equality to create equivalent equations. Interesting. Where do you see them using the properties of equality? What moves did they make when they were using the properties of equality? Well, they subtracted 4 from both sides here to get to this expression. Somebody might say they used the distributive property twice. What did they do to use the distributive property? Why did they use the distributive property? What did you notice here? Though they factored 10 out. Why might they have done that? How might that be helpful? Somebody wrote that the answer is written as an improper fraction. This is a conversation you can talk about. Because I see 10x equals 104. How did they get to 52/5? Why are we representing this as a fraction and not a decimal or an improper fraction and not a decimal or a mixed number? And that's something that's important to really emphasize in Algebra 1. So students will have a tendency to rewrite things as decimals or mixed numbers, as this is something they're used to doing from previous years. Another really meaty discussion you can have, especially for higher level students, is kind of talking about how these two equations are equivalent. Can you justify how this equation is equivalent to this equation? Because I see 5 groups of 2x minus 20, and I see 10 groups of x minus 10. How are they the same? Okay? How is this the same as this? What did they do to get from here to here? What moves did they take? Okay. And then you have some wonderings. Some students might wonder, why did they use the distributive property the second time? Why did they factor out the 10? How did they even get this, right? From here to here, how is this happening? How did they know to write this expression? How did they know how 10x minus 100 is equivalent to 10 times x minus 10? What properties did they use? Again, connecting back, we can talk about identity property. We can talk about multiplicative and additive inverse. Did they use the commutative property here? Did they use the associative property here? Right? How did they get 52 divided by 5, right? And so that's, again, another conversation you can have, just justifying that getting from here to here as their answer. How could they check their work? That's another question you can ask them. How can they prove that all of these equations are equivalent? And so using the wonder questions to facilitate the discussion in the direction that students want to go. And then the last part, I changed it a little bit. So on here it says, explain or show how these equations are equivalent, because I wanted to facilitate this on a Jamboard and give students space to kind of just write their answers on sticky notes. I allowed them to choose 2 equations and name the property or properties that prove they are equivalent. So for example, 1 and 2 are equivalent based on the distributive property and the subtraction property of equality. You can also touch on that there's also the additive inverse being used and the additive identity being used, because if we subtract 4 from both sides, that becomes a 0. That's additive inverse, and then that 0 being added here makes it additive identity, and that's why we don't need the 0. Somebody said that 2 and 3 is the addition property of equality. What else, though? What else is here? The distributive property of equality. The distributive property is also being used to factor out that 10. And then 4 and 5 is the division property of equality, but then also bringing in those ideas of multiplicative inverse and multiplicative identity. Like, we could divide both sides by 10, but what else could we do to turn this into a 1? And really, because sometimes if you had 3/5 here, it would be a lot easier to just multiply both sides by 5/3 than to divide both sides by 3/5. So really, like, letting them start to see that connection between the multiplicative inverse. So in summary, this warm-up discussion can be facilitated in any number of spaces. It does not have to happen on Jamboard, but Jamboard is a great resource for you to give students the opportunity to respond to questions in real time, and it's visible to the whole class. As I've shown in previous videos, students can also agree with other students' noticings by putting little check marks. And then reinforcing this concept of the different moves that are made to rearrange these equations and show their equivalent is going to support students throughout this lesson and throughout the rest of the unit when they are solving quadratic equations.